I am on page 16. We have 5 more terms to define. And now that you have some background with trigonometry, you understand opposite, adjacent, hypotenuse, theta, all that good stuff, we're going to look at applying those ideas to a power triangle. So this is one that will be specific for electricity, but you're going to use those principles of trigonometry. So let's start off here with real power. We need to define this. Let me find my definition so that I'm giving you a consistent one. Okay, here we go. Real power, and that is labeled for us with a W. Real power is the power consumed or used by the resistive part of a circuit. It is also called true power. So you may hear some problems call it real power, some call it true power. It's either. Okay, on the power triangle, if you go ahead and draw a right triangle, and I know you don't really know what the power triangle is yet, but bear with me here. If that's the right angle and this is theta, you are going to find true power on the adjacent leg. Okay. So true power or real power is down here. And I'm going to have to shrink this. It can be called W. It can also be called power subscript T. All of those are talking about the same thing. So let me make that come up here just a little bit. I made it too big, so let me resize it. Okay. So what's apparent power? Your book uses the VA abbreviation for apparent power. It is a combination of reactive power, which we haven't talked about yet, but we're going to, and real power that we just talked about, or true power. I'm going to use true power because that's what your textbook uses. It is also defined as the product or multiplying voltage. Remember Ohm's voltage. That's E. And current, that's I, without reference to a phase angle. And that will come later, a discussion of phase angles, not with me. So here's what I need you to know about apparent power. On the power triangle, it is the hypotenuse. So if this is your right angle and this is theta, your apparent power is going to be shown on the hypotenuse. It's that combination. Remember, hypotenuse is the longest side because it's a combination of the legs. So this is your apparent power. And the unit that we will be using is VA. It can also be described as capital P with a subscript A, power apparent. So those are kind of used interchangeably in our problems. So it is the hypotenuse of your power triangle. Reactive power. The abbreviation we're going to use is VAR. It is the component of electric power that moves between load and source without performing work. And again, as you get into your study of electricity, you will get to know these much better. I am just showing you the math behind this, but you have to understand these terms to be able to solve the math problems. So if you draw yourself a right triangle and you put in the right angle and theta, you will find VAR on the opposite leg. So VAR is going to be this leg of the triangle that is opposite theta. And this is called your reactive power. And we are using VAR as our label for that one. Okay. So what exactly is a power triangle? I'm going to draw it first and then we'll define it. So if you build a right triangle and you put in your right angle, you put in theta, you take your opposite side, which is VAR, it's reactive, and you take your adjacent side, your adjacent leg, that's your true power, and you take your hypotenuse, your VA, your apparent power, you have built yourself a power triangle. Apparent, true, reactive. That thing is the power triangle. And we're going to be using that thing to solve all kinds of math problems. So here's the definition. The power triangle is a visual representation of the relationship between apparent true and reactive power. And here's the beauty of it. The rules of trigonometry, the rules of trig apply. Pythagorean theorem applies. Opposite, adjacent, hypotenuse, sine, tangent, cosine, they work because it is a right triangle. And it will be a tool that you'll use to solve some pretty tough problems. And last but not least is power factor. And that is abbreviated as PF, lowercase. Power factor is the measure of how well electricity is transferred from a power source to a load. And there are a few facts that I need to tell you about power factor. Let me change color here. Power factor is always less than 1, but greater than 0. So it's going to be a decimal or a fraction number, a decimal between 0 and 1. Sorry about that. I have an alarm that went off. Power factor is always between 0 and 1. Another thing that you need to know about power factor. Power factor can be found by taking the cosine of theta. Power factor is the cosine of theta. Power factor can also be defined as true power divided by apparent power. Or in our book, that is W over VA. So we are going to be using the formula here, and also the idea that power factor will never be bigger than 1. It will never be less than 0. It will never be 0 or 1. It will be between 0 and 1. And then the formulae over here that we will need when we have to calculate power factor. So it's coming that you will need that one or both of those formulae. And we will definitely be doing some problems with our power triangle.